Hi guys, my name is Zach and today I'll be teaching you how to create a 2D character controller using Unity. As you can see, I've already built a level for my character here. However, you can create something very similar to this using my 2D tile palette tutorial. The link for that will be in the description down below. Before we get started, we're going to want some art to represent our character in the scene. Go ahead and head over to the asset store. Go ahead and search for Martial Hero, download and import this character. And you'll see that this character also has some animations associated with him. For this tutorial, we're only going to use his static image, but I'll do a tutorial on how to animate him later on. Once you have him downloaded, go ahead and open up the Martial Hero folder, go into Sprites, expand the idle animation, and drag idle 0 into your scene. Once you do that, you'll see that idle 0 appears over in the hierarchy for your scene. Go ahead and change his name to character. And you'll also notice that he's very small for our scene. I'm going to set his scaling to 3 on the X and Y, but this may be different depending on how you created your level. Once we have that, we actually need to give him a rigid body so he's affected by gravity. So go to Add Component and type in Rigid Body 2D. I'm not going to mess with his mass right now, but we may tweak that a little bit later. He also needs a collider so that he won't fall through the floor. If we click play now, you'll see he just falls through the world. We don't want that. So what we're going to do is actually give him a capsule collider to prevent him from falling through the world. So go to Add Component and type Capsule Collider in here and select the 2D one. That's the one we want for this. And you'll see that the collider is way too big when we first get it. Go ahead and set this to 0.25 on the X and 0.5 on the Y. I found that's a good size for this character, but it may be different depending on what character you decided to use. Now the reason we use a capsule collider is actually to allow our character to go up inclines. If we were to use a box collider, he would actually, the corner of his collision box would actually hit the slope and prevent him from going upward. Looking at this, it looks like our collider is just a little bit below our character's feet, so I'm actually going to give this an offset of 0.03 and zoom in to make sure that it is level with his feet. And that looks good. Now, if we click play, we should see that our character lands and is walking on the ground. Cool. Now, the one thing we do want to fix is we actually want our character to appear in front of the ground instead of behind it. In order to do that, I'm going to exit play, go to our character, and then in the sprite renderer, we actually just want to give him an order in the layer of 1. This means his order is higher than the ground. Therefore, when we click play, he'll appear in front of it. Cool. Now what we want to do is actually get our character listening to inputs and moving around in the world. To do that, go ahead and click on Character in the hierarchy, go down to Add Component, and type Script. Select the New Script option, and we're going to name this script Character Controller. This is going to create a new script, and it's going to put it at the root of your Assets folder and attach it to this character. So if you go to the Assets folder, you'll see it's at the top level here. I just have an empty folder named Scripts here. I'm going to go ahead and drop it in there just for organization. Once I do that, I'm going to double click on this script and it's going to open up in Visual Studio. Now that our script is loaded up, the first thing we want to do is actually create a couple variables. So I'm going to go ahead and create a couple public variables called their floats, which is a decimal point number. So one's going to be called move speed. We'll set it to 10 for now. And public float jump height. We'll set that to 10 for now as well. We're also going to set a few private variables. So we need a private Boolean called isGrounded. And this is what we're going to use to determine if our character is able to jump. We also need a reference to our rigid body. We'll call that rigid. And we need a reference to our collider. If I save this with Control S, and go back to Unity and click on our character, if we scroll down to that script that we just put on here, we'll see that we now have two variables that we can change in the editor. The jump height and the move speed. We cannot see the two private variables we set. So that public modifier is what allows us to change it here in the editor. Let's go back over to our code. And we actually need to populate these rigid body and 2D, collider 2Ds. We'll do that when we start the game. We don't want to do this every frame because that can be very intensive on the computer, especially if you have a lot of objects. That won't mean much for this simple game, but for good practice, we want to do this in the start method. So rigid is equal to get component, rigid body 2D. And we'll do the same thing for collider, get component, collider 2D. Now, when we need to reference these later on, we'll have access to them. Also need to capitalize this G. Now, what we want to do is we actually want to get input from the keyboard. We want to know when a key is pressed, whether that's the left and right arrow or the W, S, and D keys. And we're going to do that with input.getAxis. So in our update method, we're going to declare a couple new variables. So let's get a float named x-axis. And we're going to set it equal to input.getAxis. And we're going to pass this the string horizontal. And we're going to do the same thing for the y-axis. It's equal to input.getAxis vertical. This will let us know if the left and right keys or the up and down keys are pressed. And you can tell what these axes are by going back into Unity, going to your file, build settings, and clicking on player settings. This will bring up your project settings tab. But in here, you actually have a tab called Input Manager. And in here, it lists all of your axes. So you can access all of these programmatically the same way we just did. And it actually will tell you what keys will control this axis, up or down. And this will return a number back to your code between -1 and 1, depending on what key is being pressed or what combination of keys. So what we have to do is actually use that number to determine what direction to move our character. So if we go back to our code, we can actually now move our character based on these axes. So we can do something like transform.translate to move our character. The vector is the direction we want to move in. So we're going to use transform.right to get our horizontal axis multiplied by whatever our x-axis value is. So if our x-axis value is negative, we'll actually move to the left instead of the right. And we're going to multiply this by time.delta time and by our move speed. Now the reason we multiply it by time.delta time is actually to smooth out our movement of our character. Time.delta time is actually equal to the amount of time in milliseconds that has passed since the last frame. So if you're having different frame rate or your frame rate is variable on your computer, this will actually make the character appear to move more smoothly across frames instead of jumping all over the place. So we'll do the same thing for our y-axis in order to get our jump. So we'll do transform.up and we'll use our y-axis. Let's go ahead and click play and see what this does. If I move to the left, move to the right, you'll see that our character does that. But you see how he just flipped over like that? That's something we want to disallow on our character. So if we go back to our character, you'll actually see there's some constraints on our rigid body. We want to freeze rotation. We never want him to fall over. And Alternatively, whenever he is moving to the left, we want him to flip his sprite around so that he's facing that direction. So in our code again, let's do if x-axis greater than 0, do transform dot local scale equal to new vector 3 with positive values across the board. And if x-axis is less than 0, then do transform dot local scale equals new vector 3. And this time we will actually want him to face the other way. So we're going to invert our scale and we actually don't need the z for this, so I'll just omit it. Now, when we face left and right, hopefully our character will turn, or when we move left and right. So I'll save this and we'll click play and see what happens. So we actually see that he is turning the correct direction, but his scale was reset back to 1. So if you remember earlier, we actually set the scale on our character to 3. So we actually need to set it to -3 and +3 accordingly. So if we go back in here and we change this to 3, and we change this one to -3, and save it, now it should work like we're expecting it to. Perfect. Now, I feel like he's moving just a little bit quick, so I'm going to reduce his movement speed. And his jump actually isn't fast enough to overcome gravity. So if we go back to our character, I'm going to cut down his movement speed to 7 and maybe his jump to 12. Now, another problem we're going to run into is our character currently never uses that isGrounded function that we set. So you can just press the up arrow basically forever, and he'll just keep going up. What we actually want that to do is only be able to jump when he is on the ground, and we don't want it to be like a steady movement up like it is currently. So for that, we're not actually going to use the translate function that we're using currently. But before we get to that, let's actually go into our character, and we're going to actually add a child object. So we're going to add a empty object, and this is going to be called ground check. And we're going to give this a circle collider. So add component, circle collider 2D. We're going to make it itty bitty. So go ahead and just shrink this down and set its position to 0 relative to the parent. And we're actually going to just lower this down. So you can drag on the Y, or you can move it with the adjustment tool here. And we want this to be just a little bit below our character. Now what this is going to do is this is actually going to detect if it is colliding with the ground object or not. So go ahead and mark this as isTrigger. And in our character, we're actually going to go back into our script. So you can either double click on it or go to edit script there. And we need to grab our collider from our child. So instead of get component collider.2D, we actually want to do transform dot get child, and we want to get our first child. And since this is programming, the first child is always at the index of 0. So we're going to get the collider of our first child, which is going to give us the collider of our ground check. Now that we've set up the collider of our child, we need to actually start using a new method called fixedUpdate. So if you just start typing fixedUpdate outside of any method, this will auto-populate. Go ahead and select it, and it will create this method for us. Now, you want to call fixed update if you're doing anything with the physics body of your character. And since right now we're working with the rigid body of our character, we need to use the fixed update method for this. So the first thing we want to do is if collider, which we just set up top, is touching our ground collider. So we actually don't have the ground collider set up. So let's go go set up another public variable at the top here. And we'll call this public collider 2D. And we'll call this ground collider. So now we have a variable called ground collider. So if our jump collider is touching our ground collider, then set is grounded equal to true. And now we'll be able to jump after we create a jump method. So we're going to go ahead and write a new method, call it void jump. And we want this to take a float for x-axis so that you can kind of jump in a direction. And the first thing we want to do in here is if is grounded is true, then we're going to allow our character to jump. And we're going to create a new vector2 variable called force, and this is going to be equal to a new vector, and we're going to give it the x-axis and our jump height. And then we're going to access our rigid body from further up, and we're going to add force in the direction that our character wants to move, up and to the left or right, or not at all. Now we just need to call this function from inside of our fixed update. So we just need to capture our axes again. So just copy that, paste it down here, and we actually don't need the vertical axis up here in the update anymore. So go ahead and kill the y-axis variable and this translate line. Otherwise you'll have some weird functionality. And now we will just call the jump method with the x-axis whenever our y-axis is greater than 0, or with a double bar, input dot get key down, get button down, spacebar. So just type space, all lowercase, to access that key. And now give it some curly braces and hit save. And when we jump, we need to do one more thing. So if we leave the ground, we need to set is grounded equal to false, so that we can't jump again until we land. So now this should be good to go. All we have to do is test it out. So let's go ahead and click play. And we see that we're getting an error. Argument value cannot be null. So it looks like I typed something wrong. Nope. So we're getting this error because our character now has this parameter called ground collider that's not set to anything. So if you did a tile map, what you'll do is you'll actually go into like your grid and then your tile map with the collider and drag that into this ground collider. And it's going to find your tile map collider that way. If you created your level a different way, you just need to drag in the collider of whatever object you're using as your floor. Now that we have our ground collider set on our character controller, we can actually set our jump height to something like 120 and move our ground check to be more level with our character's feet. This will prevent the character from jittering as we jump around the map. So we'll click on this, and we'll actually just use the transform to drag it up to be right about level with his feet. Once we have that set, we can click play and test out our new jump mechanic. So we're now able to jump up and down, we can jump in both directions, and we can jump and reach our platforms. So there we go. Our character is now ready to be used in a platformer style game. That's how you create a 2D character controller in Unity. If you like this video, please like and subscribe. If you'd like to see something in the future, please comment down below. Thanks for watching. See you next time.